Hello and welcome to another video by CloudVersity. Today we have a hands-on session on Kubernetes. If you watch this video, you will know how to deploy a Kubernetes cluster on one of the public cloud providers out there. So we will use Linode for that. So I'm not sponsored by Linode, by the way. And then you will know how you can deploy an application onto that cluster and expose it to the public world. And the last point we will cover, and you will know after watching this video, is how to perform a rolling update on Kubernetes. So how you can make an update of your application without any downtime. If this sounds interesting to you, you should smash the like and subscribe button right now. Make sure that you're following me on social media. And I would say let's roll the intro and then we will dive right into the topic. Welcome back. So before we get started, just a short theory introduction into the whole Kubernetes topic. If you're interested in theory overall, more than like the hands-on session, then please check the channel out. There's another video on Kubernetes, like 20 minutes or something, where I do cover the theory in Kubernetes and how the architecture looks like. So in Docker, as you probably already know, we can spawn containers and put them on, for example, our Docker runtime. And if we need to scale our application, which is sometimes necessary, for example, think of Netflix or something, they will probably need to scale up their login service at the evening because more people are watching videos at the evening. So we can do this with Docker as well. We can scale up or we can create multiple containers. But the thing is, people want to access our application from all over the world, and we will have a lot of people accessing our application. So sometimes one host where our containers are running on is not enough. And then we can have multiple hosts as well. So it can look something like this. The problem here is we would need to take care of scaling up and down our hosts. We need to take care where to route the traffic to, and it's getting complicated really quick. So scaling up is complicated, scaling down is complicated. If you just have Docker as a feature in your hands. So Kubernetes kind of solves everything of this for us. And this is what I wanted to show you in this video today. So first of all, we need a Kubernetes cluster, obviously. And for this video, I will go with Linode, because if you register right now, you will get $100 discount. So what we are doing right here is kind of for free. And if you want to use Linode as well, there's a link in the video description down below, so you can just register as well. That's not a referral link, and I am not sponsored by Linode. So if you are registered, then you can click here on Kubernetes, and we want to create a Kubernetes cluster. We can give the cluster a name, so a label, and we will excuse me, we'll use the label awesome cluster. And for the region, I will pick Frankfurt because I'm sitting in Berlin in Germany, so that's closest to me. And the Kubernetes version is 1.19, or you can choose from different versions, but we will go with the latest one. And now I need to add nodes to the node pool. So what are those nodes? As you already know, probably Kubernetes has a master node or multiple master nodes. They're kind of the brain behind Kubernetes, and there are worker nodes. And we will add some worker nodes which work for us, where we can deploy our application on. We will just choose, maybe just the smallest one here. We will add 3 nodes. Click it. And then here's a summary of what you need to pay for if you create the cluster right now. So it's $30 a month, which is like the free worker nodes right here. And you do not have to pay for the Kubernetes master. This is just managed by Linode in the background, and you don't even have to care. So create cluster. And what we do need to do right now is we have to wait. So grab something to drink, fill up your coffee or your tea, and we will see each other in a second. Welcome back. So our cluster got created, and we can have a look in our dashboard what information we get from Linode right now. So we have our awesome cluster. It's running version 1.19, which is the version we selected. We have 3 cores available and 6 gig of memory. So 3 CPUs, because we have 3 nodes. Each of the nodes has 1 CPU, and each of the nodes has 2 gigs of memory. We have a total of 150 gigabyte of storage, and we need to pay $30 per month if we leave this one running all the time. And there's a Kubernetes endpoint, which is important for us. So it's crucially important because it's the only point we can talk to if we want to communicate with our Kubernetes cluster. We need to authenticate against Kubernetes, and you need to have kubectl installed on your local system. You have kubectl installed automatically if you are running Docker desktop, for example, for Mac or for Windows, doesn't matter. And you can install kubectl if you just search for kubectl and then install, you will find everything you need. Okay, so we have our kubeconfig, and the kubeconfig is just a config file in YAML syntax, which has all the necessary information in it to authenticate against a cluster. So as you can see, there's a certificate data here and our token for the admin user. So we will just copy this file or the information in the file, and we will create one YAML file on our local machine. So I will call this one kubeconfig, and I will just paste everything in here. So this looks good, just save it. And now we need to export variable so that we point our kubectl, our command line interface, to this file so it can use it and that it can authenticate against a cluster. So the command looks like this: export kubeconfig, and it's equal to the current directory in kubeconfig.yaml. And now if we execute kubectl view config, okay, it's the other way around. So it's kubectl config view. We can see that the config looks correct. So we have our cluster, and it's the same endpoint over here. So this seems like it worked. And we can check now, for example, if there are any pods running on our Kubernetes cluster. So let's check it out. Let's go for kubectl get pods -a for all. And there we go. We have access to our cluster. There are some Calico pods running. Calico is something related to the network in Kubernetes. We have core DNS and we have kubeproxy running. So why 3 times? Because we have 3 nodes. That's the reason for that. So great, we can communicate with our cluster. We are all set up, and now we can move on to finally install our application onto Kubernetes, or run our our application in Kubernetes. So let's go ahead. Okay guys, before we go into Kubernetes, let me show you in a few seconds how the application actually should look like. I prepared a container image, which is living in the Docker Hub as well. So I would just show it to you locally how it would look like. So there's a docker run command. I need to open up port 3000. I need to point it to 3000 in the container. And the image name is CloudVersity official / basic Kubernetes. I hit enter, and our application is started. And we should be able to see something here, and it's working. So locally, there's our not best looking front page ever. We have just the CloudVersity logo here, and there's a pod name, for example. It's the same name or the same ID of the container which is running locally. So that's pretty much it. And if it's running in Kubernetes, we should see or be served by the same page here. Okay, let's close this one here, and let's close the tab, and let's go ahead and do this in Kubernetes. In Kubernetes, we can execute almost the same command as we did for Docker a second ago. In Kubernetes, we need to say kubectl run, then we need to give it a name. The name is basic Kubernetes, and we need to specify an image. The image is CloudVersity official basic Kubernetes, and we will just hit enter, and it says pod created. So a pod is the smallest unit in Kubernetes, and we can now have a look if it's really running, and there it is, it's running. We have a pod, our application, and somehow the page of Linode just refreshed. Our pod is running here. It's 10 seconds old, so it's a pretty young guy, and everything looks fine. So let's check the logs really quick of this pod. So we can execute, for example, kubectl logs and then the pod name, which is basic Kubernetes. And you can see we can even look into the log files of our, or the standard out of our pod, which is running in Kubernetes. So that's awesome. Okay, what's next? Our pod is just reachable from within the cluster right now because it just has an internal IP. And we will solve this in a second because we need something like spoiler alarm service. But first of all, I want to show you a better way to define or to spawn pods in Kubernetes, which is a deployment resource. With a deployment resource, you can, or you have way more options to define the state you want to reach in Kubernetes with your application. Okay, so first of all, let's delete this pod here. Delete pod and then basic Kubernetes. This will just take a couple of seconds and it's gone. All right. And it's gone. Okay, it's terminating. So we don't want to wait, but it's just terminating right now. And we could create a deployment as well with the kubectl, but there's another way, and I prepared something for this for you. So let's have a look here in the deployment YAML. So if you want to work with Kubernetes in the future, you will be presented with a lot of YAML files. And there can be even more than one definition in one file, which is then called a manifest. But okay, let's focus on this one here first. So we have a deployment. This is it's a kind deployment. So it's a specific resource in Kubernetes. It has some metadata and it has specs. One of the specs is that it has one replica. So the deployment we are creating right now will spawn a pod, and the pod will just spawn one pod, just one copy of our image. And this definition applies to all templates which have the label app with the key app and the name basic Kubernetes. Then we have a template with the key app and the name basic Kubernetes, and then we have specs for our container. And our container has an image, which is the same we used for our Docker container a few seconds ago or a minute ago. We can define an image pull policy. So when should it pull the image, or should it pull the image at all? We can give it a name, and we need to tell on which port our application is actually serving something. So we know that it's port 3000. So let's go ahead and create this guy here. So kubectl, this time we use the command apply -f, and we will apply it deploy, and how's it named? Deployment YAML. Hit enter, and it's created. Okay, let's have a look. Kubectl get pod. There we go. 9 seconds old, a fresh running pod with our image we specified right here. And the cool thing now is we can actually scale this guy up if we want to. So we can do this here. We can say, no, we don't want to have just just one replica. We want to have 10 of this. Just save the changed deployment YAML file. And by the way, all the code and deployment files are available in my GitLab repository. I will link the repository down below in the video description. Okay, so there's replicas 10. We set it to this, and we can just execute the command again to apply the changes to our deployment. So let's do so. Hit enter, and it says configured. So it just changed the configuration of our deployment. Let's check it out. Kubectl get pods, and there we have it. We have one old container, which is 74 seconds old, and the other ones are just 9 seconds old. And we have now 10 copies running of our image, which is just awesome, because if one pod was not enough to handle all the traffic, the incoming traffic, we just now scaled up our deployment within a few seconds. And we have now 10 copies running of this image, which is awesome. Okay, the next step is to have a service, or to create a service, which will then expose our application to the outside world. I also created a service YAML here for this. As you can see, it's a really short YAML file, just 14 lines of code. This one has also metadata. It has also specs. It will serve the application, or it will listen on port 80, and it will serve, or it will redirect the traffic to port 3000 to a deployment which has the same, or which where the selector applies to. So as you know, our deployment has a label which was basic Kubernetes with the key of app, and the service will now look to the key of app basic Kubernetes. Are there any pods with this label? And this will, the service will automatically detect all the pods with the label and will load balance between those pods. So it will load balance the traffic between those pods. And the type, there are different service types. I will probably make a separate video on this. But if you say type load balancer, then our cloud provider actually will spawn one resource. It will spawn a load balancer on its side, on his side, with a public IP address, which will then point to our Kubernetes cluster to the exact same service we want to expose. And I will show you this in a second. First of all, here's a typo, I think. I think it needs to be load balancer with a capital B. And we will just apply this as well. So kubectl apply -f service YAML. Oops. Deploy service YAML. Okay, hit enter, and it's created. So let's check out if it's really there. Get service this time, not pod. And we have it here. Basic Kubernetes service it's a load balancer. It has a cluster IP, and as you can see, it got an external IP, or in this case, an external DNS entry from our cloud provider. This is just awesome. And this is just Kubernetes because it's cloud native, right? So if you want to expose a service, there's no additional configuration needed. The cloud provider, which provides you already with a managed Kubernetes cluster, they will take care of this, and they will just give you an external IP address which will point exactly to this service. And let's check this out here in Linode. We can go to good question. Yeah, I think it's the node balancers. So yeah, right. So node balancers, it's the name, and we have it right here. So it's created. Okay, but because it's new, there's no stats available yet. But you can see that it's exposing port 80. So this is correct. And nothing more right now. It's just the host name. It's the same like here. So Linode did this automatically for us. Okay, so we actually should be able to reach our service right now from the public world. So let's check this out. Let's copy our external IP address here and paste it in here. Hit enter. There we go. We exposed actually our Node.js Express application, and it's running in Kubernetes in Linode. And this wasn't really difficult, right? So that's it. We have our pod name here. And if we check this out, wait, give me a second. kubectl get pod. There should be a pod with 6Q at the end. And here we have it. This pod, this one here, actually served our application right now. And I told you that the service is actually automatically load balancing between all of our pods. And I can show you this because just take a look here. This name will change as we refresh the page. So let's check this out. Boom. 5mm, STB again, B92, NX, etc. pp. So the service takes care of this. So if there's an incoming request, it knows, oh no, one of the pods actually served like 10 pages in the last second. So now give the load or the requests to another service. It will load balance for you completely automatically. And that's an insane feature of Kubernetes. Let's scale our deployment down because we don't need 10 pods anymore. 5 pods would be enough. So let's say kubectl edit deployment of basic Kubernetes. This will open the deployment in a YAML in Vim. And here we can say, no, we don't want to have 10 replicas anymore. We will just change this to 5. And then we need to save this because it's opened with Vim. I need to say WQ to save and quit the file. And then it says it's edited. Our deployment is edited. And we can check our running pods right now, get pods. And as you can see, we only have 5 pods running and the other ones are terminating. So Kubernetes just takes care of this, and our service also knows that it is only able to load balance between those 5 pods. The other ones are not there anymore. The service will know you don't have to take care of this. Okay guys, I want to show you one additional great feature of Kubernetes because it's actually possible to roll out updates to your application without any downtime, which is called rolling updates. So we want to change our front end because gray sucks. So we don't want to have gray anymore. We want to have a black background. Okay, how can we do this? There's another Docker image or container image in the Docker registry. I uploaded this some days before with the image tag black. So we can change our deployment again, just we did before. We reduced the number of replicas to 5, and now we want to change the image. So we can do this, kubectl, edit deployment, basic Kubernetes. Okay, so let's go here, inside here. Let's scroll down. Here we have it, image. And now we need to add tag black. if you do not specify a tag, it will always default to the tag latest. Something went wrong with the indentation here. We can fix this right now. So, okay, let's save this one, and it's edited. Okay, let's check out what happens right now. Is kubectl get pod, and as you can see, there are old pods running. So they are running since, no, this one is 6 seconds, but the other ones here, 16 minutes, 17 minutes, they are running since quite a while. And new containers are getting created. And as soon as the new container is created, the old ones will be terminated. So at the end, we will have 5 containers running with fresh containers. They are not pretty old. And now they have the new image version we specified. So if I refresh the page over on here, over on the left side, it should be now black. Let's check it out. And there we have a black background. We just did a rolling update in Kubernetes without any downtime, because the service will always point only to running pods. If there is a pod with the state terminating, the service will not route any traffic to this one. And just another awesome feature by Kubernetes. Okay, I think I covered everything I wanted to cover in this video. So we learned how to create a Kubernetes cluster in Linode. We learned how to create a pod on Kubernetes and how to configure our kubectl command line interface to interact with Kubernetes at all. Then we deleted our pod because we found out that deployments are the better way to define a state in Kubernetes for our application. And then we exposed our application with the help of a service, and we were able to access our application from the outside world. And last but not least, we actually did a rolling update to make our front end even better, to improve it by a lot by changing the background color from gray to black. If you have any recommendations what I should do next, or if you have any questions, feel free to post it in the comments down below. Please make sure, if there were some interesting parts in this video, to smash the like and subscribe buttons. So this will help me a lot to grow that channel. And also follow me on the social media thingies so that you don't miss any new and upcoming videos. And that's it. See you soon.